get the value like this นะ 30.8 นะ so lastly you have to okay นะ to make a lastly value is about 31 okay sorry 31 okay นะคะ we use mathematics okay นะ to make it นะ no digit point okay sorry sometimes I forget the technical term okay next step นะ draw parallel lines นะ perpendicular to the x-axis okay so from the first นะ your point original point okay you draw this one okay yeah okay then okay นะ with the range นะ of triangular here equilateral triangle นะ here that we get and okay you draw the parallel line here like this okay here you show the thin line okay next 30 equal same range okay throughout the area okay and then okay next determine grid width okay you will get a range already and then width here okay using this equation m okay equal to size okay 60 degree times L okay you will get 20 meter okay then again same okay you draw parallel line perpendicular to the y-axis okay throughout the area okay so you will get rectangular grid okay it's square not a square rectangular okay because of the it's different width and length right and then making triangle okay making a triangle using okay making a diagonal line like this okay right here try to make it pass your intersection okay you will get the okay triangle equilateral triangle throughout the area okay so throughout the area but I cannot do do it all okay this for example okay, right but however you will get this okay same here throughout the area you will get many triangles okay but however the which point which points now which point we want the blue one okay the blue one you will get a new blue one the what is called is the tip of the triangles เนี่ยนะคะก็เป็นยอดของรูปค่ะ okay here and then okay triangle grid obtained throughout okay sorry then okay here is very important we have many okay point now from the triangles many triangles okay however we will use each point to find our locations sampling okay sampling location okay using this equation okay you will get the point the location point okay from this equation the pink x pink x pink the pink x okay red or pink I don't know now but it's like pink okay x to find this you use the blue what do you call that the uh, blue one okay the blue circle blue เนี่ย what is blue dot ละกันนะคะblue dot นะคะ now use นะ x and y now from this okay to find this okay to find here to find the new location the new location that we want using this equation and the suggestion random number here to put in the equation should be between this minus 1 and plus 1 okay so you will get every point okay the blue one okay every point you will get the new pink x okay this every pink x the total number should be 30 should be must be not should be it should be must be equal samples location or points okay not sample but we will take the sample at this point okay so another thing that should is a note okay that k is the number chosen to prevent random sample point from one grid loading on a sample on another grid okay so the random number k here should be between the range half of the range so half of the range is 30 divided by 2 or 15 okay, meter because of for example like this point for example you use the 15 so sometimes if you 15 the half of the range you will get maybe the same location okay from the right side of this point and maybe the left hand side from this point okay 1 and 2 okay so this is a suggestion if to prevent the robbery on the same location from another grid okay this is the only suggestion so after we get overall locations then okay here like this you can okay fix where we take okay using this one so this is a best way to get the representatives some of samples okay very good because of it's quite throughout the area and not no bias because of this make the okay random also but however now we have the mathematics to find okay and okay if your area okay for here if it's one kind of land and there is some pond here some pond is if we have the area like this so maybe we have to find other place okay the new because if you cannot take the soil samples in the pond okay right so you have to change another to change otherwise you cannot take the sample from the pond right you have to change okay. This is adjustment of the assessor okay next let's see we have to find the potential exposure of the people in the study site okay here the source of the contaminants can be from the soil okay the suggestion is
Professor, excuse me.
Okay.
From the slide number 47, as the equation
47
about, yes, to
Mm.
determine the random point in the area.
Yeah
As the equation, we will have a random number between 0 and 1.
Yes.
So in this case, the random number 1 is 0.417 and random number 2 is 0.71. How this random number
from
be designed?
from any technique you can find a number, okay, or just only you select one, okay, but normally in calculator you can find random number.
Oh, just
Yes, you or you select one, but if you don't want to making it bias because of your mind, you like this number,
oh,
okay, you can find
okay.
นะคะ
So random means random. It's real random.
random, not
Okay.
I like this number not like that, okay
Okay. Understand.
okay
Thank you very much.
ใช่ค่ะสวัสดีค่ะ
Excuse me, I have a question in slide number 53.
53. Okay, slide number 53. Yesterday.
No.
53. Okay, 43.
Yes.
53. Okay. เลยไปแล้วไม่ใช่ Okay, here. Okay, ค่ะ
How do we draw the line that's called เส้นปะครับ
เส้นประ
because we need to have another point or some point to
yes
connect the point with that point.
Okay, maybe I show you, but because of my drawing, okay, it's not so good because it's the PowerPoint, right? Yeah, but I would try to show you, okay, เดี๋ยวนะคะนิดนึงเพราะว่าI will tell you normally if we do we have the teaching in the class, okay, real class, not like online. Now I have example for you to make this. We have a question to you, okay, and do it at in the class, okay. นะคะเดี๋ยวขอลบนี้ไปก่อนนะคะมองไม่ได้โอเคอันนี้ค่ะ For example นะ I show you like อันเป็นสีนี้แล้วกันค่ะนี่ make it นะ like this okay so I will draw the new line นะคะ you see okay okay here okay draw it like this okay แต่ไม่ค่อยเหมือนเนาะแต่ว่ามันไม่ค่อยดี it's not so good but okay here okay นะคะเราประมาณนี้แหละเดี๋ยวไม่ใช่ไม่ใช่ได้ไหมไม่ใช่นะคะมันต้องรอมันต้องเป็นเรื่องตรงนี้ค่ะเลือกมันอาจจะไม่ค่อยดีเท่าไหร่เดี๋ยวนะคะขอลบอาจจะต้องเป็นเอาขนาดอันนี้แล้วกันขนาดอันนี้แล้วกันเนี่ยนี่ก็ดูอันนี้แล้วกันเด็กนี่
ลากผ่านเส้นตัด
ไม่ว่าโอเคyou draw okay you select the intersect of เรียกว่าอะไรนะ rectangular grid with this is a rectangular grid, right?
Yes.
This but you find okay yeah here intersection here but not everyone okay just read now find that yeah like this and so what the next is like this แต่อันนี้มันไม่ค่อยดีมันไม่เป็นตารางนะคะมันก็ไม่ได้สวยนะคะแต่ว่าอันนี้จันเพิ่นก็จำลองว่ามันน่าจะผ่านนะคะเพราะว่านี้ไม่ได้ทำมาแบบเป๊ะๆนะคะก็จะได้อันนี้ทุกอันอย่างอันนี้ก็อาจจะได้เนี่ยนะคะ เนี่ยอันนี้เราต้องลองเส้นปะนี้ดูก็ได้ก็จะได้เนี่ยคล้ายๆอย่างเงี้ยนะคะเราก็จะได้ทุกๆอันเนี่ยนะคะอันนี้ก็น่าจะต้องเป็นเนี่ยว่าอันนี้น่าจะเป็นอีกอันหนึ่งอย่างเงี้ยนะคะเนี่ยมันจะได้รูปสามเหลี่ยมนะคะ you will get เนี่ยเนี่ยเนี่ยนะคะก็ยังเป็นอย่างนี้ค่ะก็จะมีสามเหลี่ยมอันหนึ่งเห็นไหมอันนึงข้อมันหนึ่งไม่ใช่สิผิดนะอันนึงข้อมันหนึ่งหงายนะคะเนี่ยนะคะก็ถ้าอยากทำนะคะจริงๆก็ให้การบ้านได้แต่ว่าก็คุณก็จะไม่คือนิสิตจะลากตรงนี้เบี้ยวๆนะคะก็จะเบี้ยวๆอย่างเงี้ยเพราะว่าต้องใช้เรียกว่าอะไรล่ะเหมือนตารางที่ชัดเจนนะคะในตัวสเกลกราฟนะคะเรียกว่าsorry นะspeak Thai นะ in practical you need to find what we call is graph paper นะคะหรืออะไรนะคะเป็นกราฟเส้นกระดาษกราฟค่ะ graph paper to make it more it's better and quite exactly you will get exactly point and get a very good one okay ค่ะนะคะก็อันนี้ก็จะเป็นอันนี้ตรงนี้จะเป็นนะนิสิตก็จะลากไม่ค่อยถ้าใช้เพียนเปเปอร์ธรรมดาเพียนเปเปอร์เนี่ยจะไม่ค่อยได้นะคะโอเคค่ะ
ขอบคุณครับ
โอเคนี่ค่ะนี่ก็ถามก็ดีเพราะตรงนี้ก็จะเป็นปัญหาแต่ก็ไม่เป็นไรหรอกนะคะก็มีเทคนิคอื่นนะคะนอกจากอันนี้นะคะso we continue okay about the potential exposure okay, there are many kind of contaminated media okay for example soils soil the sample okay the suggestion is sample should not be composite cannot mix composite is mixing composite is mixing cannot be composite because of why normally okay soils from the land they are what we call is very heterogeneous mafic for different location we have different soil textures so we cannot mix because soil texture very important factor to influence influence the form of the chemicals existing in the soil right if sandy soil if you have contaminated with the heavy metal it's leaching very easy this is the property of the heavy metal okay reaching from the sandy soil very easy but if the clay soil if the heavy metal contamination in this kind of soil is most of the heavy metal tend to be absorbed in the soil something like that so soil texture now have is a important factor okay now influence on the contaminant existing in the soil okay so here you have to separate the sample from each location if you take the soil sample and okay next for the groundwater so here okay now if you suspect that there's some contamination in subsurface okay land okay here this is the surface soil surface this is subsurface right subsurface if you suspect there's some contaminant in subsurface so maybe the rain okay when raining okay some contaminant will reaching from surface to the groundwater so this is the here okay, for air samples you can plan, okay, the sampling at short term or long term exposure, okay, it depends on the objective and also the assumption, okay, assumption of the study, okay. But however, you need to sample at Darwin's site location, or as the prediction from mathematical model, like because of wind can change the right direction, okay, like this, okay. This is the maybe from the industrial process. If wind come here, this will maybe take this. You have to take the sample, right? This now from the west to the south. Okay, maybe you take the sample to the south, something like that. Okay, or okay, to be west from to the east, right, and north to the south, something like that. Okay, change. So this is, and also sometimes if there are some other many kind of animals living in the site, they may be absorbed the contaminant inside the body. So maybe we have to take the samples because of the some case if that one we use is add food, some plants, okay, some animal maybe already have the contaminant already inside and then absorbed in their tissue. So we also, if we use this as food, we have to take this for analysis. Okay, this is a suggestion. Sorry, this is very have a expression, but no other picture that provide to you. Okay, sorry. And okay, here now is a data evaluation. Okay, common step used for identification of contaminant for this assessment. This is, I think, it's like a basic common step. I think it's a common step. If you have some kind of data, you have to check your data is it good or not. Okay, like the first one, evaluate the quality of data with respect to the blanks. Okay, blanks mean we check that the contaminants is not from the bottle, okay, not from other source. You need sometimes I think it's better to say negative value or positive value. You will get a negative value now in your all sample, or you will get a positive value in all your sample. But how you know that this is correct or not? Okay, so sometimes you need to provide brand is no contamination, and all known sample have contamination already making by the researcher or by scientists. Okay, the chemist in the laboratory for checking that your sampling method is okay or is correct. Okay, this is I think, and also that after that, now when you have the sample and then you go to send it to the laboratory, and sometimes, okay, if you don't know now the equipment you use, okay, is appropriate, the good one with your sample or not. I will talk about the limitation of the analysis. Sometimes, okay, some equipment can measure only what we call is ppm certain level. But if your sample contaminate with the toxic compound, okay, in microgram level, okay, ppb, ppb. So it means that that equipment cannot measure this one, okay. So you get negative value all in your sample, okay. So this is the evaluate the result in relation to the limitation of analysis, okay. But however, if I am the scientist in the project, I will check first that okay, if our sample content may be very low level, if we want to check that, okay, we need to check which equipment is good for this kind of sample. This is I will check first, okay. So we will no problem about this, okay. And the third one, evaluate the significance of the level of contamination to the background data. Okay, this one I think you have known from yesterday lecture, okay. You know the background data very important because of it's clean, okay, it's clean, it's reference site, okay. You have to compare because of we want to know the subject site is contaminated or not. You need to compare with the clean one, okay. So this is you have to use t-test, okay, as yesterday I talked, okay. Okay, next, okay, exposure characterization, okay. Normally we have done in 3 steps, okay. The first one is the characterize exposure setting, okay, all environment, okay. The physical characteristic of the sources, okay. Now all information, okay, climate, or meteorology, geology, vegetation, soil type, hydrology, survey, and others if we can, okay, or we and is available, okay. And also the population, the characteristic of the population, okay, who are the people living in the study site, okay, and then have the sensitive group or okay, variety of the people, okay, we need some information of that. And also because of maybe farming, okay, the farming or also the vegetation in the area, then there may be used as the food, okay. We also have to find the information of those, okay, in exposure site and other possible location because of we don't know exactly for example, this is our study site. Maybe our scope is maybe just a trial, maybe possible, maybe if the budget and also maybe we can propose other possible also if the project is budget available, and also we want to find some facts นะคะก็บางทีก็ it depends again on the objective, okay. And okay, here then okay, you know already that we have to identify the exposure pathway, okay. How the contaminants, okay, enter the living body, injection, dermal, intact, okay, and inhalation, okay. But however, how we know, maybe the contaminants is present in everywhere, okay. The suggestion is in already shown in table 7.1, okay, here. This is a just suggestion, only suggestion, but however, if you have some kind of information, do it better or some more detail, it's okay. This is only suggestion. For example, if your sample is groundwater, maybe exposure pathway, maybe uh, ingestion and dermal. Because of people can drink the groundwater and maybe by washing, bathing, okay, right? Now, who will the suspect group? The resident L and industrial A. L is adult lifetime exposure. A is adult at work. Okay, so these are the groups that may be suspected to have the contaminant in their body. And if the sample is surface water, okay, again same, okay, pathway maybe injection or dermal and the same group, okay, but okay, L and A. Another group is L, L and C, L adult lifetime at recreation here. Okay, recreation, like recreation, the place that you have vacation, okay, making it is relax, maybe in the forest, in the mountain, something like that, okay, in this อะไรนะคะก็เหมือนชายทะเลอะไรอย่างเงี้ยนะคะ any okay any place but we consider see children because of um children okay, right to playing in surface water in river in canal, okay, so we have to consider children also for this case. And sediment, okay, sediment, we mean the sediment under surface water, sediment of the corner, pathway is ingestion, also dermal. Here, in the bracket, the accident for ingestion, we take the sediment by accident. By accident. I think everyone don't like to have it. Okay, but however, by accident, during swimming. Okay, so you can see here, children is considered to be high risk to take risk in their bodies. Okay, okay here, both in resident, in at home and recreation, and air vapor, okay, air vapor inhalation indoor or outdoor, okay, and at home, okay, at home, okay, or outdoor at recreation or at work, okay, air dust also normally we consider air dust, okay, outdoor, okay, all people here, and soil and dust, also ingestion and dermal by incidental, okay, like I said, children and okay, maybe worker, okay, don't like to wash their hand, okay, and they take the their food, okay, but already the hands contaminated with the soil, okay, then they by accidental, okay, and food, okay, only around children, okay, food. But here I think also C, but I don't know. Not it should be C also. But we don't consider for the worker ingestion the thing in the industry, right? So no need to consider this group. Okay. This is just only in suggestion if we don't know anything. Okay, next the next step of exposure is the quantification of the contaminant. Now, we use dose response concept. Okay, how can we will calculate the dose exposure of the chemical based on magnitude. This is dose, okay, and frequency, and also during of exposure of chemical in each pathway. Okay. Normally, here is a suggestion. This is very important. Okay, because of sometimes you confuse. If the chemical is very toxic, it maybe create acute effects. Okay, or maybe we call it acute toxicants. So shortage of exposure is calculated in maybe only 1 day, something like that. Okay, shortage of okay in hours. Okay, or but normally if we doing the acute test, acute toxicity test using animals, okay, in the toxicology study. Sometimes we study 24 hours, 72 hours, or 96 hours. One day, 3 days, 4 days, something like that. Okay, this is okay. And for non-carcinogen, normally we use over a period of exposure, okay, in a calculation. For example, if the exposure only 1 year, okay, so you use 1 year in calculation, okay, in calculation exposure duration. If 2 years, 2 years, or if in months, using months. Okay, carcinogen. This is different from the two cases. Okay, over a lifetime is calculated. Over a lifetime is calculated. Keywords is lifetime. Normally, okay, in the world, the average lifetime, this is a average about 70 years. Okay, 70 years. But the lifetime may for people in Japan may be longer. Okay, maybe 80. But roughly, normally we use 70 years for people in the world. In Thailand, I think maybe 75. Okay, no. But however, if you use the popular one, it's okay. But don't use 60. Okay, this is not correct. But if you study the people in Japan, maybe you use this one. Okay, but in Thailand, if you check already that the lifetime is 25, okay, is okay. Okay, we will get more confidence of our assessment. Okay. Chemical interest. Okay, again, sorry. This is maybe my quick เป็นอะไรพิมพ์มาเลยบางทีเร็วมันก็ไปนะ Key rules are classified by mouth or ingestion. I think that is better. Ingestion, drinking of food, and by dermal contact. and inhalation. Okay. Normally, okay, sometimes okay, the chemicals can be also contaminated in all kind of media or all rules. Okay, so we have to consider all medias, air, food, water, or drinkings, any kind of drinkings, and skin contact. Okay. Okay, risk of all exposures loss is accessed. Okay. Here is the equation, okay, common equation using to calculate the dose, okay, chemical dose intake, okay, equal to concentration. Intake the unit is milligram of contaminant per kilogram of weight, okay, body weight per day. Okay, concentration here can be mass per volume or mass by mass like this. It depends on what kind of samples using in calculation. Okay, R intake rate. Okay, if it's present in liquid form, volume per day. Okay, if by mass, milligram per day or gram per day, it depends. Or in air, okay, kilometer per hour. Okay. Other unit. Okay, frequency F, small f, exposure frequency event per year. Okay, how can we find this data? Maybe by interview. Okay, by interview now. How often? Okay, we get information and then you get the frequency. Okay, or by suggestion, recommendation from the equation we have also. Okay, the general number, something like that. Or F, big F, constant fraction of the chemical absorbance. This is unitless. What the big F mean? This is a fraction. If of chemical absorbed in our body, okay, in the body. For example, if we take rice, okay, we have rice every day, every meal, right? Our rice, cow. If the rice contaminated with something, for example, arsenic, okay, in every meal, okay, maybe I think I assume it's better. For example, 10 milligram is very high. This is not so good. Now, rice in your meal, okay, contaminate with 10 milligram per liter when you eat this rice, and then the body can absorb, okay, the arsenic, because of contaminant in the rice. Normally, okay, fraction of the rice absorbed, the nutrient absorbed in our body is about 0.5. So here, arsenic may be only 0.5, okay, 0.5. ก็ประมาณ5นะคะ0.5 is 50% นะคะประมาณ 50%. So 50% of 10 is 5. This is so if it depends on what kind of food you have in the taste, okay, different absorption fraction, okay ค่ะ the exposure duration years if 1 year is only how many years, okay, you have to find information, okay, from interviews, okay, and body weight also, okay. People that maybe have a tendency to be to get less, okay, breast and T is the average time period of exposure. Okay. Here is the you will see that I think that there's some recommendation the where do you use in the equation. Okay, here. So here this is the many equation is depend on what kind of sample of what kind of media you take. Yeah. Here, for example, drinking water or ingestion drinking water, water while swimming, okay, or the more intake via soil, sediment and dust, okay, the more intake soil, sediment and dust, intake ingestion of fish and shellfish, ingestion of vegetables and other produce, okay, production and ingestion of egg, meat, and dairy products. Okay, different, yeah, but based on the same equation. This different in rate, frequency, and fraction. Okay. Okay, let's see. The first one, but this is a very easy one, the most easiest one. Okay. Ingestion of drinking water, okay, I, okay, you can see, C, equal to C, concentration must be, not should, milligram per liter, okay, milligram per liter. If the contaminant present in microgram per liter, you have to change, okay, the milligram per liter, okay, and then, okay, rate, suggestion, normally people drink water 2 liters per day for adult at 90 percentile, or you can use 1.4 liters per day for an average adult, okay, median, okay, any it depends on your assumption, okay, but however, if you know exactly the data from interview, from your research, you can use that data. Okay, for example, you know that the student, okay, in school have drink the water about 1.5, the average value in student in this school, you study, okay, 1.5, you use this one, okay. This is only suggestion, okay, recommend for, I think maybe the data from American people, okay, and FE frequency, normally, okay, we drink water every day, okay, usual, so 365 days per year can be used. But however, you will see my example is depend, because of people maybe go to somewhere, okay, and different drink water from anywhere they want, okay, not only at home. So if you have that kind of data exactly, okay, we can use that one, not only this, okay, and duration, okay, is this fluctuation. Normally you have to use the real data, okay, the data from our study, and body weight. This fluctuation 70 kilogram for the maybe US people, but in our study, if you know individuals, you can use individuals or average. It depends on your study, okay. And T, this is very important, okay. Average, the average time of period of exposure. If the non-carcinogenic pathway specific for non-carcinogenic, you use the duration T here, dt times 365 days per year, okay, for finding T average, okay, but chemicals you find the dose is carcinogen, okay, you need to use this value 70 years time 365 days per year. So please make star here. So you must know now what kind of the chemicals now you want to access. This is the non-carcinogen or carcinogen, okay? So that this is very important. Otherwise, you will calculate the mistake dose. Okay. Here another equation: injection water while swimming. Okay. While swimming accident. Okay. ใช่ไหมคะก่อน accident during swimming. Okay. So let's see the parameter นะคะนะ parameter that they suggest, okay, are contact rate. Okay, this is a suggestion contact rate. Okay, 50 ml per hour. Okay, if you swim 2 hours, it's about 100 ml. Okay, so this is TE. The exposure time per event. So this information you have to make an interview to get, okay, to get this TE. And FE also, okay, so suggestion, this is the American people, so 7 days per year is the national average. Okay. So I think if Thai people maybe, I don't know, maybe 1 day, okay, I don't know, okay. And DT, okay, here is suggestion, exposure time. Okay. You can use this one on your own information, body weight, okay, and TE same as I described, okay, before, okay. And thermal intake, okay, this is thermal intake of chemical with water while swimming, wetting, and bathing. This is by diffusion. If this is your skin, this is water. Okay, no. Okay, water. Okay, the contaminant, okay, will contact here and then diffuse, okay, diffuse through skin, okay. So you can see the parameter we have to consider, okay, is A, skin surface area available for contact, okay, difference by from sex, okay, male and female, and also I think age, right, age, so this is a suggestion, okay? Children, okay, this children, this adult, okay, you can use this value, but however, I think this is American people, they are bigger than us, okay. If you do the study in Thailand or in our ASEAN, okay, when you from many places that you smaller than the American people, if you can find this kind of data from public Department of Public Health or in your government, I don't know, that respond on this kind of data, you can use that one, okay. This is only the association. You have to have this kind of factors in the equation, okay. And also R, thermal permeability constant, absorption rate, okay. or diffusion rate. Okay, here saturation value. Exposure time also, that's a saturation. Okay, you have to find the frequency, okay, duration, and kV. Okay, this is just to change the unit conversion factor from here to be to be conversion factor โอเค here นะเป็นลิตรนะคะน่าจะ conversion factor โอเค and also body weight นะคะก็อันนี้ก็ same นะคะ leverage same that okay this is just a note okay AS vary with specific activity and extended of the clothing worn okay worker exposure in general depend on time of work perform at the site and protecting clothing and extent of water use and contact okay this is depend on not only swimming okay the more contact and another kind of media index of chemical and soil sediment and dust we consider we can have that by incidental ingestion or dermal contact of soil sediment and dust okay let's see the first one okay equation for ingestion of soil okay C is concentration of chemical in the soil mass by mass okay here again if it's present in microgram per kilogram you have to change okay this is otherwise you will get the wrong unit because you need this right milligram per kilogram per day okay and then rate this is saturation value ingestion rate 200 milligram per day for children from 1 to 6 years of age okay take more they take more because they are innocent okay? they don't know okay and 100 milligram per day anyone older than 60 okay and km is conversion factor okay 10 milligram to kilogram and fi is the fraction ingestion from contaminated salt based on the pathol and people activity okay this one is quite difficult fraction ingestion of the contaminated salt we have to find this kind of information okay so this one the problem we have to find no suggestion ไม่รู้ okay okay then others same okay. Double absorption of soil this is by absorption like swimming but this is the dust or soil deposits on skin and then the chemicals if present in the soils or dust it can diffuse through skin okay here the km you can see km conversion factor and as same as saturation in swimming right you can go back to see and then R we have another kind of factor RA is the soil to skin adherent factor milligram per square centimeter okay 1.45 milligram per square centimeter for commercial potting soil maybe agricultural area okay, farming something like that and for kaolin clay this is one kind of clay okay to the adherence very good is better than potting soils okay so why is bigger ABS is the absorption factor similar นะ not similar the concept similar to the water diffusion, but however there are some different if the contaminant are the heavy metal or metals, okay, heavy metal or metals or what we call กึ่งโลหะนี่ก็ไม่แน่ใจ heavy metal sorry นะ for students who are not Thai metals arsenic beryllium and lead okay metals heavy metal you use this factor okay but if the contaminant are organic matter organic hydrocarbon like chlorobenzene naphthalene trichlorophenol or other okay you can use this factor this value okay and FE also frequency so this is very important FE the exposure frequency okay 3 times per week in fall for children this is the one kind of season okay fall okay but in our Southeast Asian we don't have fall right we have summer raining season okay and then winter only that so we maybe cannot use and 5 times in summer maybe this is because of the reason children are not attending school okay it's more frequent to go outdoor okay so that's why but however we can use our data okay, if we have okay, from the interviews air intake I think this kind of formula I think quite used more often because of exposure the air exposure from workplace and industrial and also in the city okay so that's why this equation I think used more often than others we can export to the chemical that's in form of vapor phase or in particulates so different factors okay let's see okay the rate now let's see the rate so chemical vapor if normally mass per volume milligram per cubic meter but however as I said if you get the value right this okay or milligram per liter microgram per liter or in other okay mass per volume then you have to change only this นี่ก็คือ is aware of this okay and rate inhalation rate 30 cubic meter per day for adult upper bound or average 20 cubic meter per day I think this is quite high this value people in USA I think as I know Thai people may be lower than this or Asian people if we know other value okay again we can use and here we have to find the duration of exposure this is only suggestion FE also DT will be the average same as here the particulate suggestion we can use this equation if the particulate diameter equal or less than 10 micrometer okay because of with this particulate size it can remain in our lungs okay that's why we the perchlorate, the smaller size can remain in our lung. The bigger one cannot. Maybe we exhale out from our body. For food, here different kind of food. Maybe fish, shellfish, vegetables, meat, eggs, or dairy in the products. And so different fraction of absorption. Here the first one, fish and shellfish. Let's see the position same. Just to remind you, please consider this. Apply this, the unit. And red, this is also the suggestion from American people, if you can find the data, you use data. And fraction ingestion, fraction absorption, we don't know. But this recommend based on the local patterns. I think student most often ask me, I think that you maybe use 0.4, 0.5, can, but however, it depends on what kind of fish or shellfish. Very quite difficult to find this kind of value. And this one, we use the real data. And vegetable, you can see here, same bread. There's some kind of value suggestion to us. If you eat root crops, 0.5, 0.05, kilogram per day for root crops, on 0.25 kilogram per day for white crop leaf, white crop like อย่างเช่น one kind of the white crop like อาจจะว่าอย่างเช่น spinach หรือเปล่านะคะหรือเป็นตำลึงอะไรพวกนี้นะคะ sorry นะ I don't know the type นะ white crop they can move นะ to อะไรนะคะ sorry I don't know นะ that one it's not leafy crop นะคะวายเขาพูดไม้เลื้อยเนาะประมาณนั้นนะคะ it's depend on ค่ะthis one if we can find real data ก็เราก็ใช้ you can see here absorption fraction only 0.2 this average absorption not so high now because of maybe because of plants have high fibers. So that's why only some 20% absorbed in our body. So here again now you have to find your data. And also meat, eggs, and dairy products. This is same the formula. But now the difference is the ingestion rate. You can see that here the concentration must be present in mass by mass, so it's quite different for us. The unit the milk, we drink milk, but why we know the weight of the milk? I think you can estimate easily like water, 1 kilogram, equivalent to 1 liter, something like that. But I think it's not exactly, but it's okay. We have to change, the volume to the mass for milk, And for other, it's okay. Meat, beef, egg, you estimate or you use your real data, And fractions of this kind of food, 0.44 on average for beef and 0.4 for dairy products. I think for very close value. So that's why I suggest you you for fish you can use this data for fish, but I think for the fish maybe absorption may be higher than beef, okay, because of maybe low fiber, okay. Okay, after the same, okay, I think that this is finished for the equation that we can use in our dose calculation. Okay, let's see the example. Okay, determine the chronic daily intake. Okay, the unit milligram per kilogram per day by injection of benzene. Okay, the unit is benzene. If the water concentration is 9 microgram per liter of the unit, okay, at on a work site, okay, microgram. So and the contamination also by at home, okay, 1 microgram per liter, okay. Assume injection is result of drinking only, okay. Assumption, okay, injection result from drinking only is made. There are no other pathway that this man intakes benzene. Okay. For example, by inhalation, by food, by skin contact. Now, only drinking or only, okay. Okay, so you use the first one, okay, equation. Assuming drinking rate at work, okay. If you have data from interview, you will use that. But in this case, no information. The information just only show you the example how to calculate. So assume drinking rate. At work, this man have drink the water 0.5 liter, and at home 1.5 liter per day. Okay, so we have to calculate with different dose because of different place, right? This man intakes, okay. From interviewing the worker, okay, here from interviewing information, worker works 250 days a year for 20 years and stay at home, okay, every day, and his weight is 70 kilograms. So this is from interviewing, okay. Okay, he work only one company, price range, okay. Okay, but however, now from information we can calculate. The first step is calculation benzene dose at work site, okay, because now we have to find information what is benzene. So we from the literature we found that the benzene is carcinogen. So T average should be this value, 70 years time, in the 65 day, okay. And then check all of parameter, okay, factors, okay. Here, okay. Then you replace all of value, okay, in the equation, okay. And then yes, มีอะไรไหมคะ
Excuse me, Professor.
ค่ะ
The previous equation in previous slide.
previous line เดี๋ยวนะคะขอกลับตรงนี้นึง previous line ก็คือ 74 ใช่ไหมคะค่ะ
Yes. I think this equation F capital may be eliminated because we use equation
fraction
7.21, right?
F big F ใช่ไหมคะได้ค่ะได้ก็ไม่มีค่ะ big F ไม่มี
Okay, thank you.
Okay. Actually, you should use this one. Okay, but however, it's quite difficult for me to to take ใช่ไหมอาจารย์ก็มาใช้นั้นแต่ว่าก็เป็น basic curry นะ basic basic นะ if no f fraction ไม่มี but however you know นะ actually นะ but just to provide you in more information when we drink water นะ not all 100% we still remain in our body normally only 90% but however นะ for easy นะ easy we 90% of water normally absorbed in our body okay and about 10% we lost but via urine okay something like that okay but however your suggestion is good very good but okay actually the real now you now is more accurate you need f okay, but in this textbook they do not consider this fraction okay but however we follow this textbook ก็ดีค่ะก็หมายความว่าจริงๆมันก็มีหลัก fraction ที่มันต่างไปแต่ว่าก็ถ้าเขาไม่ได้คิดนะคะคือใน textbook นี้ไม่ได้คิดละเอียดแล้วก็ไม่คิดละเอียดตามเขาแต่ว่าถ้าในความเป็นจริงมันจะมีเหมือนกันโดยเฉพาะถ้าเป็นเคสของพวก radioactive แล้วพวกนี้ก็สำคัญมากเลยพวก fraction พวกนี้ sorry for student in กรุงวานาไทยนะคะ sorry but he suggests that if to be yes good โอเคค่ะก็ได้ค่ะนะคะไม่เป็นไร so we replace now here okay then we get intakes here in my program then we have to convert the unit okay microgram into a milligram by plus 10 power minus 3นะไมโครกรัมก็นะคะ10 กำลังลบ 3 then so we will get intake this is the dose right dose นะคะmass per day okay. and at home do the same way okay ใช่ไหมคะก็ do the same way but different rate and different concentration and different duration so we don't have information of that right so we don't have so this is the I think the assumption that this man okay stay at home 30 years okay so we use this and save the average and then we will get here the answer okay but this is at home right ใช่ไหมคะก็อาจารย์ก็ 1.26 นะไม่ใช่1.2ข้างล่างอยู่นะคะขอโทษนะคะอันนี้10 unit ใช่ไหมคะ 1.26 1.26 นะ from the dose at work site okay here at อันนี้ work นะคะ work site here at home เนาะ okay so total okay 1.35 times 10 power 5 minus 5 ค่ะ milligram per kilogram per day ค่ะ this is total this is answer only for the dose okay we get dose already and next okay another one another kind is to show you example for non-carcinogenic chemicals okay different determine lifetime ingestion exposure to a non-carcinogenic chemical from eating recreationally caught fish นะคะก็คือไปจับปลามานะคะ if the concentration in the fish is 10 milligram per kilogram okay okay let's see the same equation but actually you have to use equation 7.27 this is basic equation but however you suggest you use equation 7.27 นะคะก็then everything you check okay rate you don't know rate no suggestion no information so you use the suggested value, okay, from that equation. And if also that I said we don't have this kind of value, okay, so but if compared with the meat, fish is maybe absorb more absorption in our body, okay, better absorption, and meal also, okay. Uh, Maybe we assume frequency only 10 meals per year, and duration lifetime is uh, uh, estimate for about 30 years, okay, here, because we don't know. Uh, this is the recreational rate, maybe not 7 years, 70 years because of maybe working working period of lifetime, okay. But however, now if we have information from interview, we use that one, okay. And then, okay, because of this, the chemicals is non-carcinogen. You have to use 30 years only, okay, in calculation like this duration exposure, and then okay, you will get this replace everything, okay, you don't, okay, and it takes of the chemicals, okay, from eating fish, from the recreational horse fish, okay. Okay, answer. Okay, uh, uh, then go to the final step of the risk assessment, the risk assessment and risk characterization. Okay, so this quantification, okay, is meant to find the value of the risk. Okay, so normally there are 2 points or 2 effects of the response of the body. Okay, for non-carcinogen or from carcinogen, non-carcinogen, and non-carcinogen. Sorry, non-carcinogen and carcinogen. If the non-carcinogen suggestion for chronic and subchronic exposure time, if the exposure time or period greater than 7 years so it's called chronic effects. If the period of exposure 2 weeks, from 2 weeks to 7 years, okay, called subchronic. And for the case of cancer exposure time, no level of exposure time, okay. I mean, if only once you expose one time, then you will generate the carcinogenic effect. If you remember the dose and response curve of carcinogen, the remarks of that graph, no safe value, not safe value, no threshold value เอากลับไปดูก็ได้บางที ไม่รู้ wording เดี๋ยวไม่ตรงนะ the assumption is one molecule of the chemical or the carcinogen can cause cancer or tumor ขอโทษนะย้อนกลับไปเยอะๆหน่อยนะคะก็ย้อนกลับไปนิดนึงนะคะเพราะว่าbecause of sometimes this is I think quite new information for all of you นะนี่กลับไปไหนแล้วโอเคไม่ได้สอนแล้วเหรองงอ๋อทุกทีอาจารย์จะงงเองนะคะอาจจะไม่ได้สอนงงมากเลยแต่บางทีก็หลายคอร์สเนาะงง Actually, I have 3 subjects related on risk assessment, so sometimes I confuse that I'm already talks confused by myself confused ขอโทษทีค่ะ ถ้ามันไม่มีก็ the assumption โอเคไม่มีหรอกค่ะอ๋อยังไม่ได้พูดถึงหรอกน่าจะพูดแล้วนะคะ ตอนแรกๆเลยโอเคเอาไม่เป็นไรที่เกียจย้อนกลับไปนะโอเค sorry ขอโทษนะจ๊ะกลับมานะคะ come back to our okay here no level of exposure will not generate if once you expose to the carcinogen the cancer effect can be happen during your lifetime. Okay. 70 years. Okay. If you expose during your childhood, okay, maybe the cancer just only remain. It can be happen again during your lifetime, 70 years. That's why. Because of sometimes normally people who have cancers because of cells that have already old, okay, and sometimes the response of allergy, the response is not so good, okay, not so good. So that's why sometimes cells turn to be different as one, and then turn to be cancer. Okay, that's why. Yeah. Okay, let's see the quantification of risk now for non-carcinogen. Okay, we can use the RFD reference dose, okay, or reference concentration RFC for calculation the non-carcinogenic risk, okay, or in the bracket hazard quotient, okay, for oral and inhalation exposure, respectively. This IFD for oral in by mouth, and this is air exposure. Okay, but I will talk later that actually by air they are also available the IFD. Okay, and different dose. Okay, here normally the unit, okay, is milligram per kilogram per day, different or reference concentration. Okay, if reference concentration actually, sorry, I think this is you may confuse. I think I will delete this. Otherwise, different dose normally present in milligram per kilogram, but different concentration. The unit should be concentration mass per volume. Okay, mass. Okay. Okay, let's see the indicator of toxicity. Okay, here. This is the dose and response curve now for any kind of chemicals. Okay. Normally, the indicator now for indicate the potential of toxicity is LD50. This one is mean lethal dose 50%, or the dose required to kill the members of the test operation after a specific test duration. Okay. Now here in the test we have different dose. Yeah. And population may be not human. Okay, sorry, but this picture I can find, but it can be animal or other kind of bacteria, plants can use, but normally we don't use people now as our test. Okay, but after test you will get you will find the curve like this. This is a cumulative of operation. Here is the okay. We increase the dose okay until this increase the dose until this. So the population increasing that right until all okay all days at this dose okay at this dose. But however, if we want to compare the toxicity potency, we can use LD50 because of some kind of other kinds of chemical, maybe the slope like this. Okay, maybe like this. Okay, different. Okay, but however, now if we want to compare, we use at 50%, you will get different. Okay, value. Okay, by only draw the line, and then you can draw the straight line. Okay, then through the slope, and then you will get the point, the dose at the axis. Okay, and then okay, you will get the LD50 as the indicator. Okay, however, now we also have many kinds of indicators like EC50, effective concentration. So we just only see the abnormal response now of the test animal. Any kind of abnormal, the response, okay? So that one is effective concentration, or can be radical concentration, okay? Can be the unit, it depends. However, all of these can convert to LD. Concentration normally mass per volume, right? But for LD is mass per mass. Okay. However, these kind of parameter can be converted together from one to one. Okay, it depends on the information of the test that we can convert. Okay. Okay, this is a response curve. Let's see the reference dose. What is this? Normally, you can see that this kind of curve, okay, it have some small response, okay, small response like here, around here. So it means increasing dose, but the response is not so high, okay. And if we accept, okay, this one for people who exposed to the chemical, not so high, okay, we cannot observe the adverse effect, okay. So this is we can use it as a different dose at any point. It depends on the toxicologist, okay. They have the assumption of the study and also what kind of animals they use. Okay, so here reference dose is the amount of the chemical can be take per day without any adverse effect. Okay, so for example, like this, a man can take about 100 milligram of caffeine per day. This is the information without any adverse effect. So roughly, calculation the reference dose, okay, 100 per 50 kilogram of weight. So the reference dose is 2 milligram per kilogram per day. This is very easy, but roughly calculate. But however, for the reference dose, real one, okay, for non-carcinogenic effects, it's not easily like this. Okay, they have tests, many kind of tests, and then it's quite difficult also to find this okay, different dose. But this is an easy way to explain to you. Okay, and okay, how can we use reference dose or reference concentration? Okay, non-carcinogenic risk can use the this formula intakes divided by reference dose, you will get the Hassett quotient or HQ. Okay. Now, also, if the first one we will use for oral or dermal contact, okay? But now for inhalation, you can use the reference concentration if it's available, okay? Also, this same intake divided by reference concentration, okay? How can we know the risk? Now, if the HQ less than 1 is acceptable, okay? Because of it's less than reference dose, right? Okay, so that's why it's usually safe. Okay, here, note. Now, if you find information, reference concentration, maybe we can see milligram per kilogram per liter or milligram per cubic meter or microgram. That it depends. Sorry, I cannot provide all. For example, here, exposure concentration, okay, of something, I don't know, okay, here, about the concentration of the non-carcinogen is about 0.005 milligram per kilogram. The reference concentration find from the literature about 0.01 milligram per cubic meter. So find the HQ. Okay. Here, intake divided by reference concentration. You will get HQ 0.5. So it's less than 1. So negligible hazard. Okay. Like this. But however, I think from my experience, okay, this is the like screening method ก็คือจริงๆ actually นะ we can have rapid screening นะ we can use intake and divide by RFC นะ to rapid calculation and find likely risk นะ risk assessment นะคะ okay and next okay hazard index okay because of we have various kind of pathway and also various kind of chemicals, right? So however when we get HQ, okay, many HQ, however that we have to sum all. So HI is the sum of HQ from many kind of substance. Then we will get like a total hazard risk, but we use hazard index to as a summation of all kind of chemicals. Okay, so again same the index HI index if greater than equal or greater than 1 is indicates harmful. Okay, we can use for chronic or subchronic exposure. Okay, this one again for non-carcinogen. Okay, let's see here that I said. Okay, okay. The example of RFC and RFD. In this textbook, okay, in this textbook, RFC concentration they provide 2 units, milligram per cubic meter and milligram per kilogram per day. Okay, here you can see. Now, if here, this is the RFC in this unit. Okay, here in the bracket in this unit. Okay, but if you find from other information from website, sometimes then the unit ไม่ใช่ the unit sometimes the reference the words reference concentration will be the reference dose same as the oral, okay? But in my experience, the correct one should be reference dose because the dose is mean mass per mass, not concentration, right? So, but for this book, this textbook, they use this. I also that this is very confused now for students. Why the concentration is shown like the unit of mass by mass, but how can because of this is a textbook, I think maybe it's okay. It should be a reference dose, okay, IFB, but now for the textbook it's shown like this. So I'm also during teaching, I know that is confused to you, okay? But as my knowledge, the reference dose it should be mass per day, okay? Okay, and here, okay, oral. For oral intake, it's no problem. You can find only this unit, okay? And okay, let's see the other information from this page. Okay, from this page. You can see here, species, okay, they use, okay, inhalation and oral. Sometimes they did not provide, okay, the information of the species test, okay, not available, only this part, okay, only oral, okay, and because of the test maybe from various kind of source, okay, from many kind of many researchers. So now another information you can find is this, okay, effect of concern, okay. If we use mouse, they use mouse in the test. They see the hepatotoxicity generate in the mouse, okay. Hepato is liver, toxic to the liver, okay. And you can see the different kind of the effects, okay, and different kind of the animal test. But however, how can we use for if we make an assessment for the humans, actually, that thinking around my it's quite difficult for you also. Sometimes animals like the effects that occur in animals sometimes maybe okay at the assumption is maybe man also happens, okay. We just only have an estimation like that, okay, like that. Something happen in any test animal, maybe also in our human body also. We can just only estimate like that, okay. The information, that's why they have to provide this in this page, okay. Okay, next. Okay, we have 1 hour. Risk quantification for carcinogen. Okay, this one, slope factor. Okay, derivative is based on assumption that every dose causes a cancer to man, or there is no safe dose. Okay, this one, I think that's a mention. Okay, okay. Every dose or every molecule of the carcinogen, okay, can cause cancer. Okay. Now the dose response is like this. Again, the straight line, not curve. Okay. So increasing dose, increasing cancer. Okay. The slope factor is risk occurrence of cancer, okay, divided by dose. This is a risk, okay. Y-axis slope. So we can use SF slope to find the risk. Okay. By if we do the dose and we find the SF for each kind of chemical, we can calculate the risk. Okay. And here the risk for the carcinogen, okay, SF times dose or dose is chronic daily intake or intakes that you learn already, okay, everyday intakes over 70 years, okay? And SF is low factor. You can find this factor now from anywhere, especially for US EPA, WHO, WHO, many, sometimes from the company that they produce chemicals, they also provide. Okay. You can find it's the SF. Okay. The result, if you make a calculation and you get the value, you have to check if the value less than 10 power minus 6, it means it's safe for people, okay, that exposed to the chemicals. Or this value, we can say 1 in million people, okay, 1 million people, we can accept less than 1, okay, a million people. Okay, here is a EPA unit risk of slope factor, okay, in different pathway, inhalation and oral. You can see now the unit, there are 2 kinds of unit, concentration and per milligram per kilogram, okay, yeah. Why we have different units? Because of we can use in different situation, okay, but you can see the different, okay, different value we can use in different situation, and we'll talk later, okay. And okay, here is a process now, risk characterization, okay. This is the, I think, common. Organize the results. The first step, organize the result of dose and dose response study, exposure duration, route and absorption adjustment. Okay, as I talked before, quantify the pathway. How many pathway, possible pathway, potential pathway for cancer risk and for non-cancer hazard index. Okay, combine all risk across pathway, add together cancer risk and add together hazard index. Okay, if you have HI, many HI also, HI, you combine, make a sum, and then summarize the result. Okay, here, the explanation. You have many risks of I in many pathways, many chemicals. You just make a summation, you get the risk total, okay? And for non-carcinogen also, you make a summation of hazard index, or for chronic or subchronic, okay? Make a summation. The result, if less than 1, this less than here is safe. If greater than this value is not safe. Okay. Here, is this to know the potential organ to be cancer if there is loss of exposure for source identification. Okay, because of sometimes back to the identification. Now, if you know from the information or from the sample analysis, okay, that when we check the chemical, we found benzene in water, in the air, or chloroform in the air, nickel in the air, vinyl chloride in water, in food, in the air. Okay, so what kind of organ tend to have or tend to be cancer? Okay, or tumor, get tumor. Okay, so let's check. Okay, tumor site. Okay, we have to find first. How can we find this information? Okay, you can see different pathway. Sometimes you will get the same tumor site, okay, leukemia. Sometimes different pathway you will get different organ of tumor site. Okay, and okay, here also different pathway. You get different tumor size. This one is provided by toxicologist in the test in the test of animals, and we can assume that maybe that the people take the same chemical and export in the same way of pathway, the same pathway. Okay, we get the tumor site. Okay, then we will go to we will we can use this information to characterize the risk of each chemical. Okay, let's see the risk screening. Okay, it needs to reduce the number of chemicals evaluated in the risk assessment. Then the toxicity screening is a tool for reduction the number of the risk agents. If you remember, as I said before, maybe we have more than 100 chemicals in the study site. For example, in industrial state area, like Maptaput or in very close maybe to in Pathum Thani, forget the name already. I remember Maptaput. Okay, there are many industrial and emission. Okay, so many kind of organic compounds or particulate. Okay, many. So how can we reduce the number? What is the what kind of chemicals are the priorities? So this one, okay, we can use for eliminate some chemicals. Okay, here risk factor. Okay, we can calculate risk factor for each chemical. Okay, by using this equation. Okay, Rij. I is chemical, J is medium, C concentration of the chemical. This is by our analysis. And T is toxicity of chemical, cancer or slope factor in concentration unit. Here, okay, here. Back to this. Okay, here, in concentration unit. Okay, we can use this. Because it's really easy, no need to find body weight, frequency, everything. Okay, just only use this, but this is for screening only. Okay, then with this equation you can find every risk of all chemicals. Then combine all, you will get the total risk factor. Then you can find the relative risk of each chemical using this equation. Okay, RR equal to RIJ divided by RJ here, total risk. Okay, so this is the remark. A separate RJ is calculated for carcinogen and non-carcinogen. You can use the chemicals that have the lowest contribution to the total RJ is dropped from further consideration. The lowest contribution, what is the lowest? But however, commonly we use 1%. If the contribution less than 1%, we will drop or get rid of chemicals in our assessment. Okay. Yeah. Okay. And have this page. Okay. The dissolve factor in concentration, mass per volume, we will use this one. Okay, let's see the example. Using a toxicity screening in order to reduce potential risk agent in groundwater contaminated with agent A, when mcg is microgram per liter. Agent B, 18 microgram per liter, agent C, 10 microgram per liter, and D, 5 microgram per liter. And using this equation, concentration times toxicity. Okay, so here is the example. We don't know A, B, C, D, but however, the step we have to check what is the A, B, C, D. This assumption that all contaminants cause cancer, so then we can use low factor in concentration unit in screening method. Okay, A, B, C, D. Check given as low factor here. Okay, and this is assumption, just a example for you. Okay, and then we can calculate CT times toxicity, like each toxicity, okay, and we will get the risk, each risk like this, okay, and then combine all, you will get RJ like this, okay, and then find the R relative using this, yeah. Each risk divided by total risk, you will get the percentage of each chemical contribute in the risk. Okay, you can see that the RR of B only 0.89%, less than 1%. Okay, B. So it is excluded from the suspected group for our assessment, right? So next step, for example, more details in assessment, no need to consider agent B. Yeah. Even you can see the concentration is higher than C and higher than D. Okay. Otherwise, if you consider only concentration, you may be waste of budget, or you have to pay more. Okay, in study. Okay, so using this, maybe you can eliminate many chemicals in the study. Okay. Okay, next example. Okay, 9.8. Okay, if I say like this, you can find this. Okay, in the textbook. Okay, if chapter 8 and example 8.9, I'm to it from the textbook. Okay, determine the chronic hazards of a male adult community exposed to nitrobenzene in the air and nitrogen dioxide in the air also to compound based on the following concentration and exposure condition. Okay, here the information they provide นะ in ppm unit, okay, and provide the exposure time, okay, exposure 6 hours per day and duration 5 days per week and years lifetime, okay, lifetime. They not change their work, okay, lifetime, okay. This is the from the textbook, okay, so I don't know นะคะ okay. Solution: the concentration is first convert to milligram per cubic meter using the following equation. As I said, you cannot use directly the information they provide to us, because of otherwise you use the unit, you will get the different dose and different risk, right? So this is the formula normally used in conversion ppm unit and to the milligram per cubic meter, okay. Concentration in ppm times molecular weight, okay, have to find, divide by 22.4. This is, I think you know, and this one T is temperature, okay, Kelvin, and T is temperature, okay. It should be changed into Kelvin, okay. It should be Kelvin unit, not Celsius, and P divided by pressure divided by 1, okay. And then now you find the molecular weight of nitrobenzene and the nitrogen dioxide, okay, and okay, replace in the equation. You will get the unit, correct unit in for next calculation, okay. The intakes are compute. Now you can use the concentration, okay, for compute the intakes of each chemical, okay. ได้เรียบร้อยแล้วนะคะ so replace everything the information, okay. Here you can see we use rate 30 cubic meter per day. Inhalation rate or respiration rate is quite high, but this is maybe American people, okay, they use very high one, okay. And okay, this is information they gave. And if you see this 7 kilogram and okay, maybe you confused now. I think this is 70 year and 70 year also duration, because lifetime, okay, lifetime maybe already 80 minutes. So they shortly write written like this, okay. Sorry, I should provide and then make it clearly, but however now, sorry now, because of copy from the textbook, okay. And then I found that it's not so good now as an example for you, okay. But however, I think most of you are scientists or engineer, you know, okay, that why they not present this kind of value. Okay, we finished the intakes now already, the nitrogen, benzene, and nitrogen dioxide. Then we must calculate the Hassett index, okay. So here both chemicals are non-carcinogen, so that's why we use this formula to find the Hassett index or Hassett quotient นะคะก็เป็น quotient ก็ได้นะคะโอเคthis should be Hassett quotient and then you summation of HQ นะคะ okay you get this, okay. and RFC you have to find. Okay, this is we just obtain from as above. Okay, and concentration we don't use, but we have to uh, provide information, but we don't use because we get already this number. Okay, and then after we get the HQ, each HQ summation, you get the HI. Okay. If now you, I like to make a note here that in the textbook they did not use HQ. They used hazard index for all, even in each only one chemical. But however, I think in general, they commonly use SQ for calculate one chemical and one pathway. If you check in the US EPA and others, okay, it's quite different. Okay, and maybe because of there are some change. So it depends. I think HI is okay also. Because what is a quotient? Quotient is just only mean the result of division. What ผลหาร quotient is a result of the division การลบการหารคือ sorry but sometimes I forget the keyword. Okay, then you will get finally hazard index here greater than 1. Okay, greater than 1. So is toxic is very toxic to this man. How can we consider? If we consider the value 9.3 and value 0.55, you can see that nitrobenzene contribution more. Okay, I think more than 90%. So we have to consider the nitrobenzene maybe give more contribution. So if we have to do something to reduce the risk, we have to reduce the nitrobenzene at the source. Okay, in the air contamination, I don't know. If in this case nitrobenzene using and no cover in the machine, something like that, you have to do something for control the emission of nitrobenzene from the source. Okay. Yeah. So this one we have to describe what will happen, what is the effect if nitrobenzene, if you find some information about the effect of nitrobenzene, maybe heart effect, maybe kidney, maybe lungs, you have to describe that from the previous research. Maybe we have the information that if nitrobenzene very toxic to the heart or to the lungs, kidney, and every place. Okay? So you have to provide this information in the report. Okay? Let's see. I think this is
sorry before I have a question.
โอเคค่ะได้
Slide 98 in the bottom summary you mean nitrobenzene concentration give hazard index or hazard quotient.
greater than 1.
Yes, I mean hazard index is the summary of hazard quotient. So hazard index actually always greater than 1. So this is hazard index or hazard
quotient. As I said, if you go back to textbook นะคืออย่างนี้ถ้าเกิดอันนี้นะคะเดี๋ยวพูดเป็นภาษาไทยก่อนแล้วก็เดี๋ยวบอกเด็กนะคะคืออย่างนี้ค่ะในตำรา textbook อันนี้เขาใช้ HI หมดเลยไม่ว่าจะเป็นเรียกว่าแต่ละตัวเขาใช้ HI แต่ทีนี้ มันก็จะมี confuse เหมือนกันเวลาที่นิสิตเนี่ยเวลาไปดูในเปเปอร์อื่นเลยพวกเนี้ยเขาจะใช้ hazard protein สำหรับตัวchemical เดี่ยวๆโดดๆเพื่อแยกให้มันชัดเจนแต่ถามว่าใช้ index ได้ไหมก็ได้เพราะว่าจริงๆแล้วมันก็เหมือนกันแหละมันก็คือเอาอะไรคะเอาตัว CPI หารด้วย IFD เนาะมันก็คือเหมือนกันแต่ว่าอยู่ที่ว่าเรานิยามเป็นอะไรแต่ในที่นี้อาจารย์ก็เลยมาเปลี่ยนเพราะว่ามาเปลี่ยนจาก textbook ตัวนี้เพราะว่าเวลาส่วนใหญ่เดี๋ยวนี้มันใช้คำว่า hazard quotient หมดเลยเขาจะไม่ใช้ hazard index เขาจะใช้ hazard index ก็ต่อเมื่อมันอะไรคะมันเป็นผลรวมแต่ทีนี้ในนี้เนี่ยอาจารย์ก็ follow ตามเดิมของเขานะก็ขอโทษด้วยจริงๆอ่ะจะใช้ quotient ก็ได้
ทีนี้ก็คือเราจะต้องพอเปรียบเทียบให้น้อยกว่า1หรือมากกว่า1เนี่ยเราจะต้องเอาแต่ละตัวมาเปรียบเทียบไม่ใช่ไหมครับไม่ใช่เอาแบบ
แต่ตัวเหมือนกันคืออย่างนี้จริงๆแล้วในที่นี้เนี่ยสิ่งที่เราจะต้องทำอันแรกก็คือ summation หมดแต่พอเรามาดูเนี่ยว่าแต่ละตัวเนี่ยตัวไหนมันน่าจะท็อกซิกเราก็มาดูแต่ละตัวว่านี้มันมากกว่า1อันนี้มันน้อยกว่า1เพราะฉะนั้นตัวที่เป็นหลักก็คือตัวนี้ถูกไหมคะ
ครับ
เพราะฉะนั้นตัวนี้จะต้องทำไมคะต้องมีการจัดการอันนี้คือแต่ combination ก็รวมกันนะ combination ก็แต่ว่าถ้าคุณจัดการอันนี้ได้หายไปปื๊ดสมมติว่าไม่ใช้เป็นตัวไนโตรเบนซีนเลยถามว่ามีไนโตรเจนไดออกไซด์อย่างเดียวโอเคเพราะว่าอะไรมันน้อยกว่า1ไม่ต้องจัดการก็ได้ใช่ไหมคะแต่ในที่นี้เนี่ยโดยหลักการของ assessment คุณยังไงคุณต้องหา HI คือผลรวมทั้งหมดมาก่อนแล้วคุณก็ค่อยเหมือนกับว่าอธิบายต่อว่าเนี่ยนะจริงๆแล้ว contribution เนี่ยมันมาจากอะไรคะมันมาจากไนโตรเบนซีนค่อนข้างเยอะคือเราจะไม่
มาเปรียบเทียบใช่ไหมครับ
ไม่เราจะไม่หยุดประเด็นเราจะไม่เว้นประเด็นไหนเลยแต่ว่าในทางทุกอันที่เป็นประเด็นเราต้องมา discuss หมดเลยเพียงแต่ว่านี้คือ follow ตาม step ก็คือเราก็มาหาอะไรคะHI เป็นผลรวมทั้งหมดก่อนนะอะไรเงี้ยนะคะแต่อันนี้จะเป็นโคเทนก็ได้นะคะจริงๆก็โคเทนก็ได้ถ้าตามนี้ควรจะเป็นโคเทนเนาะแต่ว่าถ้าเกิดคุณไปดูใน textbook อ่ะมันเขียนใน hazard เดี๋ยวคุณงงอีกทำไมอาจารย์ใช้อันนี้อาจารย์จะทันปรับเป็นทันสมัยให้มากขึ้นเท่านั้นเองอันนั้นมันเก่าละอาจจะงงนะคะค่ะนะคะ
นี้ขออีกนิดนึงครับสไลด์89ครับ
89 98ไป89students who are not Thai I usually explain now why okay if you want more explanation also I will okay อันนี้นะคะคือ
ตรงนี้ที่อาจารย์เขียนเป็นน้อยกว่า10ยกกำลังลบ6แล้วก็น้อยกว่า1เนี่ยครับอันนี้หมายถึง total หรือว่า
total
ใช่ไหม
ใช่ก็คือสุดท้ายเนี่ยนะคะเราจะดูตัวไหนเราจะดูตัวนี้ทั้งหมดไม่ว่าจะมีกี่ตัว risk เนี่ยมาทั้งหมดเลยรวมกันแล้วเนี่ยนะถ้าผลรวมน้อยกว่า10กำลังลบ6นะคะอันนี้แปลว่า safe แต่ว่าถ้าเกิดว่าคุณได้ผลมากกว่า10กำลังลบ6ก็แปลว่าไม่ปลอดภัย
อย่างข้อเมื่อกี้ตัว chronic hazard index เมื่อกี้มันก็มากกว่า1คือข้อมันเนี่ยคือก็อันตรายแต่ว่าตัวที่ส่งผลตัวที่อาจจะไม่ส่งผลก็คือตัวที่เป็น 0.05
ใช่คือเราก็สามารถที่จะแบบรู้ไงใช่ไหมแต่ว่าอันนี้คือเป็นยกตัวอย่างนะมันมีแค่2ตัวแต่ถ้าเกิดว่ามันมีตัวอื่นขึ้นมารวมอีกใช่ไหมรวมอีกแต่ว่าไม่ถึง1หมดเลยไม่ถึง1หมดเลยแต่รวมกันแล้วเกิน1ทำยังไงคุณก็ต้องไปลดตัวใดตัวหนึ่งที่แบบว่านั่นแหละคุณจะลดตัวไหนได้ง่ายมันก็เป็นเมธอดว่าไป consider toxicity อะไรอีกนะว่าตัวไหน toxicity มากที่สุดเอาตัวนี้เอาตัวนั้นคือมันมี criteria ของการพิจารณาอีกค่ะอันนี้ก็คือเป็นแบบว่าเหมือนกับเบสิกให้คุณดูก่อนเนาะรู้ก่อนเฉยๆแต่ว่าเวลาไปทำงานจริงอ่ะคนที่จะต้องทำเรื่องนี้คนจะต้องแบบว่าอาจจะเหมือนกับเนี่ยเป็นทางจริงๆมันก็ต้องไปเกี่ยวโยงกับพวกเขาเรียกว่าอะไรนะ public health นิดๆนะคะก็จะรู้ศาสตร์ทางนี้เหมือนกันเพราะว่าพวกเนี้ยเราก็จะรู้ทางด้านนี้แต่ว่านะมันก็ต้องอาศัยความเลยคะเหมือนเรียกว่าช่วยเหลือกันเหรอเป็นทำงานร่วมกันนั่นแหละนะคะเพราะว่าบางทีเขาก็จะไม่รู้เรื่องของอะไรล่ะการวิธีการค้นหาอะไรอย่างเงี้ยเขาอาจจะเข้าใจนะเวลาผลมาแล้วอย่างเงี้ยเขาอาจจะเข้าใจว่าจะต้องทำยังไงแต่ว่าเวลาสเต็ปอะไรต่างๆนี่บางทีทางเอนจิเนียร์ก็จะค่อนข้างคืออาจจะเขาเรียกว่าอะไรมีสอนมากกว่ามั้งเพราะว่าฉันเท่าที่จะไปดูนะพวก public health ก็จะเหมือนกับคนละเมธอดเหมือนกันเขาเวลาที่เขาทำแต่เขาจะรู้เรื่องของเอฟเฟกต์ของต่อร่างกายอะไรเงี้ยควรจะต้องเป็นคอนโทรลอะไรตัวไหนเขาเรื่องรายละเอียดเขาจะรู้ตรงนั้นค่ะ
ขอบคุณมากครับ
โอเคค่ะน้องอ่านต่อsorry for ใครอ่ะother student not Thai what he asked about the value of this okay if now why this value is if we know that it's higher than one and if this value for nitrogen benzene ละกันnitrogen benzene is greater than one นะwhy จะบอกว่าไงนะถามว่าทำไมถึงไม่ we can make a summation or make a explanation that this one is greater than one and this is the giving the toxicity นะ potency or the risk why we have to make a summation of this this one is we know already but however the step common step you have to combine all value first and then we consider in detail which one giving more contribution on this kind of risk โอเคนะคะก็in ไม่เป็นเคสนั้นก็ช่างเขาอาจจะเข้าใจก็ได้นะคะก็โอเคค่ะ example next example นะคะก็เกือบสุดท้ายแล้วเนาะอีก2สไลด์นะคะใช่ไหมคะอีก3โอเคก็ is this a carcinogenic evaluation for the risk cancer risk for women working in the environment contaminated with acrylonitrile in the water and in air and water with this concentration and giving the information here okay solution okay first you different part where you have to calculate those okay for each pathway first one the inhalation pathway is calculated okay in this you again you have to go back to use 7.26 equation like this 20 cubic meter per day okay and then here we select because maybe women okay inhalation rate may be smaller than man okay that's why here the concentration present in milligram per cubic meter already no need to change the unit right and then okay you replace all information like this and again here 70 years because so if we use a T average like this it means that acrylonitrile is carcinogen okay cancer risk carcinogen the cancer risk is mean acrylonitrile is carcinogen okay and then you get intake of acrylonitrile via inhalation okay like this and then okay intake by drinking water okay again we will use that 7.22 and replace this okay you can see this one why milligram per liter and then we will not change You can see that the unit uptake is 1.4 liter per day. So it's need not to change to any unit, right? They can eliminate the liter. So this is okay ไม่เป็นไรค่ะก็ไม่ต้องเปลี่ยนอะไรเลย and same okay just only the different information provide and then we get the acrylonitrile intake via drinking water this body and then because of it is a carcinogen we have to find slow factor for inhalation and oral okay and find in somewhere acrylonitrile okay in website US EPA WHO or in company okay that produce this chemical okay and you get this the unit is milligram per kilogram per day per actually per kilogram per day per milligram per kilogram per day this is you have to aware my power minus 1 okay the unit okay then find the carcinogenic risk calculation intakes times slow factor okay you get this already and slow factor and this okay so here you can see that each if you make a unit like this 3.7 เกิดเป็น 0.37 นะคะใช่ไหมคะคูณ10 กำลังลบ 6 and 0.720 แสดงนะคะ you will see all is safe right all pathway is safe if you consider each pathway okay because it's less than 1 in million right you safe but however summation is point okay here point 1.14 times 10 power minus 6 the dose is greater than 1 in million right greater so the summation of this indicate that the acrylonitrile present in water and also in the air is not safe for this woman this working place is not safe for this kind of this worker okay so she has potential to get rid of cancer okay then for protection therefore it suggests that this woman should not extend her work here because of what because of if we look back for information this is only working 1 year only if you cannot do about the acrylonitrile contamination okay in this environment this woman working only 1 day and she already she already has risk okay in this working site so if possible you should move this woman to other place first okay and then we have to improve the quality of air and water by any kind of engineering technique okay to reduce the concentration of acrylonitrile in the air or in the water if you can okay โอเคเข้าใจไหมคะอันนี้ก็จะเป็นตัวอย่างที่อะไรนิสิตนะกี้เนี่ยที่ถามนะคะโอเค any questions about this example ไม่มีนะคะ okay other student do you have any question on this or not I think I like to give remarks on this summary and this characterization. We have to describe actually more than this, okay, about what is acrylonitrile, is what will affect. This is actually we know only the risk, but we don't know what kind of organ that have the risk, right? So we have to describe more in the report. In the real report is big, but only this the example just only show you what should we do next. Okay ค่ะก็จบแล้วค่ะก็ finish about the assignment I think you can do now นะคะก็ and the submission I think if you can finish on Monday or next Tuesday is okay allow 7 days or 8 days you can I think you can do. And submission where you send back my Gmail, okay, my Gmail address, you send submit. Now you take if you do with your handwriting, just only take the picture, okay, and then make it PDF file or okay, now send it back to me นะคะก็คือส่งมาในรูปของไฟล์ PDF ไฟล์ or it's better if it's present in PDF ไฟล์ ค่ะจะตรวจง่าย and again I like to ask you about the examination okay when you like to have an examination hello ค่ะจะสอบวันไหนคะคือจะได้นัดอาจารย์ธรรมรงค์รัตน์นะคะ you have the available when available day เมื่อไหร่คะ
Let us check first. Please give minute.
Okay ก็ who are the representative สุภาวินีหรือเปล่าเอ่ย representative ของห้องใน class this class can I contact you สุภาวินี
Yes, you can contact me, but just let you know I am not the representative, but you can contact me.
โอเคก็โหไม่มีเฮดเหรอคะไม่มีแบบไม่ใช่เฮดหรอกเป็นแบบอีกที่ชาย18 he proposed 18 November it's okay or not